Good. Before we go into this part of the exercises, or at least try to understand a little bit in practice what it means to talk about responsible AI, I saw from the discussions that we had at lunch and also at the breaks that there is somehow some kind of amazement that AI, we can be doing AI and working in AI without really needing to do a lot of big data and to do a lot of training with data. So I want just to start to remind us all about what actually, how AI works and how can we make it work also in cases in which we don't really have the data. So basically, and I suppose that you all know this, AI is a computer system, an algorithm, which gets some input, some perceptions, and then makes some suggestion, makes some decision, makes some action, makes some impact in one way or another. AI, like I said before, cannot be separated from the environment where it is. So it perceives this environment and acts or makes decisions or makes suggestions about this environment. How does AI get to perceive anything? It's just a software sitting in a computer somewhere. So what we do to give inputs to AI? We give it, for instance, sensor data or sensor values. We can also just type or other way interact directly with the AI system, or of course we can use some type of data sets. So this is AI once we have the algorithm, and once the algorithm or the model is designed, we can use it in many different ways. But how do we get to this algorithm, to this model? That's where the issues of training data come into place, like you know. But we can make algorithms, and actually people have been building algorithms for millions of years, not just 50 years or so, but even before we had computers, we did algorithms. Any recipe for apple cake or for curry or whatever, this recipe is an algorithm. It has a set of instructions, which you follow those instructions, and hopefully, if you do it well, you get a very tasty curry or a very nice cake. But that is an algorithm. And we have been building algorithms, we people, for thousands and thousands of years without necessarily having to let algorithms emerge from analyzing data or training, using data to train. So what does those algorithms do? They help, or they are built to support making some type of decision or taking some type of actions. That is what we call the decision rules, the steps, the content of the algorithm. What are these decision rules? Are, for instance, what helps you decide when should the lights in this room be turned on or off? Or is this a dog or a wolf that I'm seeing in this picture? The rules, there are rules that the system uses after it has been built, the model. We have a model which helps the system decide is a dog or is a wolf. Another model is a model which helps us determine whether a specific person with some type of symptoms has diabetes. Or, for instance, is this person which has some kind of characteristics qualifying for a loan from the bank. So all these type of rules, all these type of decisions is what an algorithm, a model does once we have designed that model. Where these rules come from? They can, of course, come from data, but actually they come from many more different things. They can, for instance, be decided by the one with programming. He just looks around, I think that this is a dog, so a rule about dogs is that they have a tail and 2 ears or whatever. So these are kind of usually not the most smart ways to build models, but it's possible. Just the person who is typing the code just makes the rules as they go, possibly randomly. Another way to do it is to ask experts, like what Frank was talking with the indigenous communities. They are the experts in reindeer herding. They have all kinds of knowledge about when the reindeer should go to this place or that place. So we can ask them what are the kind of rules, what are the kind of models that they use to make their decisions. We can ask many people and then combine all that together. Or of course, we can extract these patterns from data. And we can, again, do many more different ways to get to the rules. What is different and what somehow we tend to forget nowadays is that there are two ways to get to this model. Either we build or we train. We can also combine it, but just to make it simple, we build the algorithm or we train the algorithm. Let's look very briefly about what we do when we build the algorithm. Basically, we handcraft a model based on whatever rules, and then when we have this model, we give it some new data, a picture of a dog, and then the computer provides a result. This handcraft model, this has been the way to build AI systems until 15 years ago. Any AI system which is older than 15 years, which are many, and they are still being used, all of those have been built more or less by handcraft, by building it by hand. And how to do it? We could think about the simple one. What kind of rules, what kind of model can we have to have a system that automatically turns on and off the lights in this room? You might think it's a very stupid type of AI system, but let's just go with it because it's a simple one to put in my slides. We can let, indeed, like I said, the programmer decide, but maybe the program is someone which has not really much experience, and it just decides, like, if it's after 8 o'clock in the evening, then the light should be turned on. And it works in most cases, except if you are there where we live in the north of Sweden, where today the light went off, or it became dark at 2 in the afternoon, and in the summer will never get dark. So maybe this rule doesn't really work all over. So a way to build the systems is to sync and resync and participatorily build this type of rules. So for instance, a smarter way to do this, where it is? A smarter way to do this would be, if it's dark outside, then turn on the lights. It's a bit better than wait for 8 o'clock because it's not always at 8 o'clock. But then this means that the system would be turning on the light at any time that it gets dark, independently of what is happening in the room. So maybe a better rule, and again, this is what expertise and trying out and so on gets us there, is if it's dark outside and there is someone in the room, then turn on the lights. Then so far I have not collected any data. I'm just building this model, which is working, better or worse, in a good way. Then maybe you can realize that, yeah, but maybe what happens if that person is sleeping? Maybe they don't want the light on if they are sleeping. So we can change the rules again. If it's dark outside and there is someone in the room and that person is not sleeping, then turn on the lights. Again, I'm building this system which will work perfectly after a couple of iterations like this. No data was used at all to train this system. Many systems can be built in this way. We just need to dare to see what kind of questions, what kind of expertise, what kind of knowledge do we have about turning on lights in a room, which enables us to decide on the rules without needing to collect data. Of course, we could keep here, I don't know, a video or a camera taping out whenever people come in and out and what they do with the lights. And we had to do that for 1 million rooms. But actually we have experience enough, all of us, to make this by hand, and the system will be working quite nicely after a couple more. Maybe there are a couple more exceptions to put there. So we build a system, an AI system, which can take a decision, is adaptable to the context, because it can check whether it's dark or not dark or people are there, without having any training data at all. It works. If we are going the other way around, like I say, by extracting patterns from data, then what do we need? First, we need to collect the data, and like some people might say, more data is better, not always, but we need to collect enough data about how lights are turned on and off in rooms. And we also have somehow to tell the system what do we expect the result to be? Again, I'm being very simplified. There are many ways, and you all know about it, supervised, unsupervised, and so on, but just let's make it simple. We are going to do this, and for instance, give the system not about lights in the room, but we give it 1 million pictures of cats. We tell him more or less what we expect a cat to be, and then this goes around and around and around and around and around until the system comes up with rules about what is a cat. That is the model. So at this moment, with the training, the only thing we did was exactly what I did with these iterations about the room. It was come up with the model. Once we have the model, then we are going to use the model exactly in the same way that we would be using a model that is built by hand. And that means that we need to get some new data, current data about this room or about this animal, and we are going to use this model that we created to build an answer. So then we can show it this picture, and the system, if it is built well, it will say it's a cat. We give it this animal, and the system will say it's not a cat. Again, in this case, we do need to fine-tune, to relearn, to make some more iterations, to talk about, to get the right system, like the one I did with the lights. So at the end of the day, what we want to have in AI is a model. How do we get to the model? Can be with data, training data, or can be with common sense, with expertise, with all kinds of things. And actually, there are many, many, many situations in which we don't want or we cannot learn from data. Can anyone think about a situation in which you cannot build an algorithm that with using data? Sorry? No. Algorithms, you want to build a model without having data or not having data. Whether the data is noisy or whatever, doesn't matter. Just something, some kind of decision that you would like to take that you don't need data to build that algorithm. No? I have a couple of suggestions. The first one, simple arithmetic. You don't want to learn what is 2 plus 2 by collecting data about all answers that people ever gave to that question. Why not? First, because you have very clear rules. The result is exactly determined, and there is no uncertainty at all. In the data that we'll have, noisy or not, I can guarantee you that there are people who made mistakes about 2 plus 2. So you will have data in which it says is 5, is 3, is 2.5, is a cat, is a flower, whatever kind of data is there. You don't want to learn simple arithmetic by making a training system on the data. Don't try that. It's stupid, it's no use. It gets worse results than just using the rules that you have learned. Another one, ride a bike. Do you think you can ride a bike by training, looking at data and looking forever at people riding bikes? You will learn it yourself? No. And why can we not do that? Because it needs really real-time sensory feedback. You need to have to feel the bike and feel the balance to do it yourself. Looking at other people doing this will not help you. It is embodied, it's about your own body, the way you sit in the bike and so on. And you need to have this continuous control over the bike to have the feedback for what you do. So you don't want to learn how to ride a bike by using training data. There are many more. List sorting, which is one of the first things you do in any programming class. It's also, there are rules for it. No use to look at 1 million of lists being sorted or not. They will have errors on them. You just want to apply the rules. Thermostat regulation. Again, there are rules for these things. And like this, we can have many others. Maybe one which is interesting, morals. We don't want to learn morals or to learn our own ethical behavior by looking at people driving over chickens or over people or over whatever else. That's not the way to do it. So in cases, and what are the characteristics of models that are not good to be built using data, are models which are deterministic, models that are fully specified, situations in which safety is critical. You want to use the rules, you don't want to learn from the mistakes that come in the data. Situations in which you require a continuous or a closed loop between what you do and what you react, in which you require exact correctness. You cannot afford to get it wrong. All these cases, and there are many situations in the world that fit these characteristics, in none of these cases you want to train a model from data. You want to build the model yourself. So training data is very useful, is applicable in many, many situations, but there are limits. And there are many situations, and this is just a small example, in which we are not at all benefiting from building a system by training the system using data. Okay? And not all AI requires that you train a system from data. You can build perfectly useful and complex and perfect AI systems without using data, like what Frank did with the COVID things. I mean, a little bit of data you always need. You always need the data to apply the system to, but to build the model, you not always need the data. Good, that was just to kind of clarify all these discussions about data, no data, whatever. It's perfectly fine to do AI without training from data. There is also perfectly fine to do AI by training models from data, but you have to be able to decide and to know when am I going to build my model using data, or when I'm going to build my model by defining the rules myself. And these are just some of the characteristics when you don't want to train it on data. Just one more thing, we were talking this morning about what is intelligence, what is not intelligence, how AI is or not similar to intelligence, to human intelligence. Downstairs, if you come up the stairs in the first floor, there is this picture, which is very badly taken, which talks about all different types of intelligence in which people can excel. It's downstairs, you probably can make a better picture than this. Only a very few of these types of things AI is even able to do. AI is not able to do bodily kinesthetic intelligence, is not able to do spatial intelligence in most cases. It has some possibilities of doing the linguistic and the logical mathematical intelligence, but most of it's not something which AI systems are able to do. So human intelligence is much, much more than the systems that we are doing. Good. Any questions on training data and building models? Anything like that? Then we go to the exercises, which was what this session was supposed to be about. And I will ask you to use Slido, so if you have your telephones or your machines, I will show the code for the slide in a moment. So we are going to look, going to try to build an AI model here. We are not going to build, we are not even get to the decisions whether or not we are going to use data or not. We are just looking about the responsible aspects of building this type of systems. Looking at what are the principles that we need to address, looking about question 0, is this something that we want AI to do? Looking about what kind of trade-offs do we need to make between the principles. So this is the case, again, is a very simple case, and it's kind of possibly or completely not realistic, but it will help us do the work. We want to build an AI system which is going to decide or to support the decision about kidney transplantation. Kidney transplantation is very usual, but it's quite complex because you need to find the right donor and to match donors between the donors and the patients. You want to make sure, at least in my story, that the people who need most will be the ones who get the kidney first. What does it mean to need most? That is the issue that we are going to explore. And most of these type of systems, the ones who exist, which are in many cases manually, the decisions are made manually, they classify people in low, medium, and high risk based on their what they calculate to be the probability that they will reject that kidney. They don't look at other issues. They don't look at age, they don't look at health of the patients, they say, this is what is fair. We have a kidney, we have a low bunch of patients. Which one is the one which will have the least likelihood to reject this kidney? And then we use that. So that's the only thing. Maybe they take the age of the patient into consideration, but they don't take issues of gender, they don't take issues of background, they don't take issues of their social context, of their previous lifestyles, all those kind of things. Now, they have the risk of rejection and they have the age of the patient. And now all of us are hired to build this system. The company comes to you, you guys are AI experts. We actually even have here all the data about our previous patients, or you can go and interview the doctors or whatever you want. Let me please build this system for us. What should be the first thing we ask ourselves? Anyone who listened to my lecture this morning? Sorry? What should be the first thing we ask ourselves when we get this request? Question 0. Is AI the best option to do this thing? Are there better options than AI? Why should we be doing AI and how are we going to use AI? So let's start with that one. This is the Slido. If you go to Slido, you can do it together if not all of you want to do it. We can also discuss with each other how it is. And I see, sorry, that my system went a bit wrong. This one shouldn't be here. Yeah. Good. Everybody got it?
1 minute.
Sure. Good. So then the question 0 would be, is AI suitable to develop a system to characterize patients waiting for kidney transplantation? Yes or no? Those are the options that you get on the slide. I will put it in a minute. Yes, AI is always much more accurate and more robust and much more rational. Yes, but only if the system has some explanation on it. Yes, but only if the system is as fair as possible. Or no, no way, this is about life and death. We don't want AI to be doing it. So let me just move to the Slido. Where is the Slido? Now I have to find my... Up, didn't went there, go there. Oops. Okay, anyone else is still deciding? Have everybody voted already? Or are you still voting?
Still moving around.
Still moving. Oh yeah, now it's more. Yeah, okay, good. Okay, let's start thinking about this. What are we saying? That we want the system, sorry, I have to stay here. We want the system to be as fair as possible. More or less 50% of you, a little bit less, think that yes, we should be using AI if we can make the system as fair as possible. For instance, that means not taking personal characteristics into the decision, which means that fairness is not about equity, the ones who need most, or the ones who are most likely to take good care of this kidney get it, but we don't look at their characteristics. We don't look at their jobs, we don't look at their families, we don't look at their previous lifestyles. We just look at the age and the likelihood of rejecting the kidney, which potentially means that we are going to give the kidney to someone with a 50-year-old without children and with a previous lifestyle of smoking and eating fat food and things like that, instead of giving it to a 30-year-old female with 2 kids at home and would never smoke in their life, because we don't have this data to decide. We think that we need to abstract from all of that. But maybe someone can say something. We think seemingly that accuracy is not important, at least it's not the most important. Can someone comment on why you select accuracy or why you didn't select accuracy as being the most important thing? Anyone wants to comment on the accuracy issue, the bottom one? Why is accuracy not a relevant characteristic for this system? No one? Maybe the ones who thought about, no, we should not build this system with AI. Why did you choose no?
To consider what you mentioned before, like to have like to follow certain morals and ethics, I think, that maybe AI cannot really fully comprehend.
So deciding between the 30-year-old mother with 2 kids instead of the 50-year-old male with no children and a lot of smoking in the past. Exactly. Good. And there is quite some people who think, yeah, it's fine to build these systems as long as we have explanations. Can you explain why you chose for explanation? No one, you are just kind of randomly choosing buttons. Can also be. We are tired, it's enough. Okay, so let's continue our questioning. So the question 0, we have it already. Now we are going to think about values. Value alignment is a very important type of issue when we talk about responsible AI. Most of these systems and these guidelines and principles that have been defined by UNESCO or the European Union or the United Nations, all these type of things, they come with a list of values that are important to address. Unfortunately, we cannot address them all. There is usually some type of time constraint, capability constraint, and so on. So we do need to look at which are the requirements that are the most relevant, the most important for a specific, this case, the kidney transplantation. These are the list of principles or ethical requirements that have been identified by the European Union on their document on guidelines for trustworthy AI. This is the document that was at the basis of the regulation that came much later, the AI Act. And these are the list of things that at that time people thought were important. There are many more of these lists. Like I said before this morning, most of the lists are kind of similar. But now for this case, for our kidney transplantation decision support system, we need to identify which are the most important of these ethical requirements that are relevant for this system. So now what I'm asking you to do, again with the Slido, is to rank these requirements. Decide which ones are more important, which ones, as you are building the system, you are putting the most effort in guaranteeing that those things are part of the design of your system. And we go back to the Slido. If I find the slide, sorry, I go back to the Slido and I should be able to go to the next one. Good. Now you can rank. You just can order them as you find the most important, putting in top the one you find the most important. Okay, let's look. I don't want to take too much time. It's late in the day and there is still the ideathon. So let's continue. One thing which we are saying now, we as the group which is deciding on this, we didn't found that accuracy was relevant when we were deciding whether or not to use AI. But now it seems that we think that once we decide that we are going to use AI, accuracy is the most important of the requirements. Accountability is also an important one, non-discrimination and fairness, privacy, and so on. It doesn't show the other ones. First question to you guys. Who should be answering this question? If we are doing this in the real life, if there is a need for building this type of systems, who should be deciding on the ethical requirements for the system? It's us, the computer scientists in this room? It's the patients themselves? Is the doctors? Is the lawyers? Is the administration of the hospital? Is the provider of the AI technology? Who should be answering these questions? Any idea? Sorry? should be a collaborative approach, a participatory approach, and who should be part of this discussion? The user. Who is the user? Who is going to use this software is probably some administrative person in the hospital who is going to decide which kidney goes to which person. Is that the user you mean? Maybe. But more? Who should be more on it? The clinicians? Policymakers? Patients? Who? Business? Yeah. And you think that all of them will have the same ranking? So if you are the patient, which one you think is the most relevant? Accuracy. And if you are the developer, which one of them is the most important? As a developer. Why? I would go for the ones who are the easiest to implement, no? You are the developer, so let's use what is important for you. Or the lawyer is the ones you can justify, you can run on with. So are we going? And another issue, do you understand with what these things mean? What does non-discrimination mean? Do you think everybody will have the same understanding? Or what means human oversight? Is having someone there looking at the laptop while the system is making these decisions? So how do you think that we should go in real life if we have made the decision, yes, we are going to build this AI system for the kidney transplantation? What more should we do in real life than just looking at this list that I gave you? Any ideas? One of them you already said, find out the group of stakeholders that should be involved in taking these decisions. Maybe another one is about what exactly is the meaning of these characteristics in this specific context for this specific problem. Other ones is about how much is going to cost to implement all this stuff. Are we going to have enough budget to do it all? Who is going to decide what costs more or less? At the end of the day, things cost time, cost effort, cost money. So there is much more that needs to go behind it. Of course, it's important to think about the ethical principles. But again, like AI or like anything else, they don't exist in a vacuum. We need to ground them in some meaning. So let's maybe continue a little bit. One more question, which is, let me start this again, which is about trade-offs. We only have limited time. We only have limited resource. Now let's think about how are we going to use those resources. How much computational costs should we put more? So if we are going to build a system that needs to be explanatory, to provide explanations, that means that you will need to build that explanation into the system. It's not just making a system that is accurate, which is what we probably would be doing, but also think about how much computational cost are we going to put to include explanation. Yeah, let's go do that one. I think I have that one. Let me, how is this? How much cost are we going to ask or to use from our resource, from our time, to make explanation? Is that no extra cost? We should just do it? Or is it whatever it costs? It seems so far that's the one. Okay, whatever it costs. How we are going to pay for it? It is laudable, of course. It's important to have explanation. But now, how are we going to get this? Who should be paying for it? The patient, I heard. The poor patient already doesn't have kidneys, and now he says going to pay for the explanation why he gets a kidney. Okay. Who else should be made to pay for it? Sorry? Sorry, I cannot hear so well, so you have to shout a bit louder. Who should? Ooh, health insurance. Okay, so then it gets all our health insurance for all of us gets more expensive because the system needs explanation. They are not paying it by themselves. Who else? Who? Government. Sorry? The public, eventually the public, your taxpayers, maybe, that's where it comes from. But if then taxpayers are going to pay for this explanation, and it's going to cost whatever it needs, what else should not be done to pay for the explanation? The money has to come from somewhere. That is only our taxes only go so far. What should the government not be doing in order to put explanation on this system? Again, this is kind of not something which we need to do now or to think about now, but it's the type of issues which shows that responsible AI is not just follow a list of questions and not just about the system that we are building. There are many more connections, many more issues. If the government is going to pay for this, or the health insurance is going to pay for this, what are they not going to do? Or how much are they going to grow our health costs? It shows that it is an interconnected world. I just want to do one more of these ones, but I have to stop this one for a minute. Where do I stop it? Okay. Okay. Another one. Oops. Oh, you need to stop voting, sorry, because I changed the question. Anyway, now the question, it will not change much. The question now is, accuracy, we all learn and get to believe that accuracy is one of the most important characteristics of this type of systems. We also rank that as the highest of the values that we want to implement. So if we are going to make a system that is 5% more, imagine the system now is 80% accurate, and you are going to invest on making it 85% accurate, how much can that cost? Improving the accuracy of the system. No more, whatever it costs, something in between. So of course, it's not explanation, it's accuracy. You understand that. Okay, so it seems again we think that, okay, here we are a bit more modest. 50% increase should be enough for 5% accuracy. And we are kind of divided between whatever it costs and 50%. Do you ever think about this type of cost issues while you are building on accuracy, improving the accuracy of the models that you are building? Anyone thinks about it? How many hours of night hours working on your programs it is worth to create a little bit more accuracy? Do you think about it? Who thinks about it? Good. Why?
Oh, well. So in the academic context, let's say, that those few person in general matters a lot, but also this is like, how to say, the reward for the number of hours is decreasing the more you go like in accuracy. Like the last one person is the most difficult, and it would take you more and more and more time. And this is exponential.
Yeah.
So yeah, so I think about that. Yeah. So in the end, you have to give up.
Anyone else thinks about it? No, no one wants to think about accuracy? And if the accuracy is in this case is for kidney transplantation support, decision support system, we think that 50% more cost is worth. But if the accuracy is for a recommender systems for Netflix, would 5% better accuracy on the recommendations be worth 50% more cost? Why not? We care about accuracy. It's what the paper, when we submit our papers, what they measure it on. Why is Netflix different? Anyone wants to comment on that? Sorry? The stakes are lower, so if you get it wrong, you just have a boring evening. Okay. Okay, I think that we have done more or less. I have another exercise you can do at home if you want, and if you want me to, let me start that one again. This one is doing the same thing, but now about a system that is about a recruitment system which is determine who is going to be selected to interview for a job or not. Like you know, there are many systems like that nowadays, and it would be good if you think about it with this type of questions that we have. Of course, the questions that we did now here were extremely simplified, extremely like black and white, is yes or no or whatever. In real life, this is much more complex. For instance, the trustworthy AI assessment list developed by the European Union to deal with that. Where is it? I lost it. Hey, where is my... This one, so this document of the European Union to deal with trustworthy AI and with this list of requirements comes with an assessment list which is around 250 questions long, which already shows that no one is going to do it because no one has time to answer those 250 questions. But at the end of the day, is not so much about what are the questions or how many questions are there, but it's really to create this feeling that it is not just about building the best code that we can. Of course, it's important to build the best code that we can, but we need to think about the context, the question that we are answering, who is really matters, to whom does this question matters, and how much are we able to invest on other issues than just the quality of the code. And those other issues are often kinds of issues that are not really what comes first to us as developers, as engineers, and that's why it's so important to talk about these issues with other disciplines. I think I stop here now because we are kind of quite late. If there are any questions, I'm happy to answer your questions, and I can go to the beginning. Yeah, here, up, I lost it, up. You can contact me by email, you can contact with me via LinkedIn, and any questions or any issues that you want to continue the discussion, I'm happy to answer. That was it, and we can go now to the ideathon. Thank you all. Thanks.